In this video, we're going to be looking at linear sequences. So here we've got some numbers from a linear sequence. Now, what makes this a linear sequence? Here you'll notice that I've worked out all the differences, and the differences are all 2. And this is what makes it a linear sequence, the fact that all the differences are the same. You should also know that sometimes this is called an arithmetic sequence. It's just another name for linear sequence. And the main thing about them is, it's when the differences are all the same. Now for these sequences, we need to work out the nth term. Now what is the nth term? Nth term is a formula which gives you every term in the sequence when you replace the n with what term you want. So let's go ahead and look at a couple. So here I've got 3n plus 7. This is the nth term formula for a linear sequence. So how do we get the sequence from this formula? To get the first term, we replace n with 1. So 3n means 3 times n. So here we have 3 times 1. We can put that in brackets, 3 times 1 plus 7, which is 10. Let's try the second term. So this time we're going to replace n with 2. So we'll have 3 times 2 plus the 7. And that gives us 13. Let's do one more and get the third term. So to get the third term, of course, we're going to put n in as 3. So here we've got the first 3 terms of our linear sequence. So let's go ahead and check that it is indeed linear. So the terms are 10, 13 and 16. And we can see the differences are the same. Brilliant. In each case, it's 3. I'd like you to also notice that in the formula you had 3n and the difference was also 3. Now this will help you make the formulas, which we're going to do later. So just note, when the formula had 3 in front of the n, the differences were also 3. So when we go and do make the formulas, whatever the differences are, that's the number which we're going to put in front of the n. So we can look at the sequence we had at the start and try to work out the nth term for it. So the differences are all 2. So what are we going to put in front of the n? And you should have said 2n. We need to have 2 in front of the n. Now the next thing is you need to add or subtract a number onto this 2n to make the formula work perfectly. Now one easy way of doing it is to see what the number would have been if there was a term in front of the first term. Of course the first term is the first term, so there really isn't a number before it, but we just want to see what the number would have been if there was one. And since they're going up in 2s, the first term is 3. So the term before it would have been 1. And that's a positive 1, a plus 1. So the number we need in front of the 2n is that plus 1. And that's a neat way to find that number. So again, what you do is you find the term in front of the first term, the term which would have come before it with that pattern. And that number adds on to the 2n to complete the formula. Now let's look at another way of doing it. Now at the moment we've got our formula as 2n. So what we can do is put n in as 1 to see what the first term should be. And that will give you 2 times 1, which is 2. But the first term is actually 3. If I'm putting n in as 1, I should have got 3. But I got 2. And you should be able to say I need to add 1 to correct this formula. So we're just going to put a plus 1. And we get that same formula as before, 2n plus 1. So both methods give the same answer. Now it's up to you which one you want to use. So here we've got another linear sequence. So let's go ahead and work out the nth term. The first thing we'll do is work out the differences. And we notice the differences are all 5. So we know it's definitely a linear sequence. And we also know the formula is going to be 5n since the differences are 5. So the next thing is to see if there's a number we need to add or subtract to correct the formula. So we can put 1 into this, which will be 5 times 1, which is 5. But the first term is actually 4 and we're getting 5. So we need to subtract 1 to correct it. So we're going to put a -1 by the 5n and we get the formula as 5n minus 1. Or if you like, you can just work out the term before the first term using this pattern. So in this sequence we're adding 5, so going backwards, subtracting 5, we get -1 and it gives us the same formula. Let's look at another example, and again we'll work out the differences first, and we can see the differences are all a -4. So our formula is going to start off with -4n. With these ones, just be very careful to make sure you say -4 and not just leave it as 4 because the sequence is going down. Now, what's the number to add or subtract to finish this formula? So let's go ahead and put n in as 1 to see what the first term comes out with at the moment. So we have -4 times 1, which is -4. But it should come out as 15, not -4. Now, if it's coming out as -4, but you want it to be 15, what's the number you need to add to get 15? And you should have said 19. That's the number we need to add to make this formula correct. So we'll just put plus 19. And there we have it. I hope you found that video useful. Support us by liking, subscribing,